Hey guys, all right. Happy Monday. It's actually Friday for me. You guys haven't even started taking your test yet, but I'm getting in the recording. So we're going to start chapter 3. We're going to learn some more derivative rules. Conceptually, this isn't too difficult to stuff. It's like power rule, quotient rule, product rule. It's called the chain rule. I'm just going to do some quick derivations here before I get into the actual notes. So the chain rule says that if you have a function inside of another function, which is kind of confusing, we'll talk more about it. What you're supposed to do is take the derivative of the main function, so f prime, right, the derivative of the f, and then multiply by the derivative of the stuff that's inside of that, okay, because we can't forget to take the derivative. So let's do an example here, and I'm gonna put 2x plus 1 quantity squared. Okay, we'll say y equals, and let's do this using rules that we already learned. And so using rules that we already learned, like the power rule, I would have to FOIL this out first. And so by FOILing, I get that y is equal to 2x times 2x, 4x squared, plus 2x, or plus 4x, plus 1. Okay, and then we could take the derivative and say, well, the derivative would be 8x plus 4. That is absolutely correct. Okay, and that's not using the chain rule. Okay, so again, this is not using the chain rule. Let's attempt to use the power rule that we already know, and we have y equals 2x plus 1 squared. Well, if you guys attempted the power rule, right, without knowing the chain rule, so this is going to be wrong, let's see what we would do. We would bring the 2 down. We would multiply by 2x plus 1 to the power of 1, okay, and we'd be done. Well, look, that says that the derivative should be 4x plus 2. That is wrong, okay? It's wrong because you need the chain rule because you have this function inside that we never took the derivative of, okay? And so let's do this, okay, using the chain rule, which I'll do lots more examples on the actual notes. So if you have y equals something, 2x plus 1 to the power of 2, the chain rule simply says, do the power rule that you're used to. So let's bring the 2 down. Let's multiply by 2x plus 1 to the power of 1. That should all be familiar, right? That's the power rule. But we haven't taken the derivative of the inside stuff yet. So we have to multiply by the derivative of whatever is inside there, which would be 2. That's the chain rule. And when you simplify that, clearly this would be 4x plus 2 all times 2, which would give us an answer of 8x plus 4. And check it out. We know that we did it correct this way because we got it to a polynomial and used the power rule. Over here, we tried to use the power rule, which doesn't work. This is wrong, right? Because you don't have that chain part where this says, look, this is the inside stuff. I have to multiply by that. Okay, so let's jump into the actual notes and do some problems. And this is just a game of how many problems you can do, and you'll get better at it. Okay, so looking at this should be a little bit less intimidating. The chain rule says, let's bring down our 100, just like the power rule. Let's multiply by the stuff, x cubed minus 4x plus 1 to 1 smaller, which is 99. But you haven't taken the derivative of this yet. So the chain rule says you also need to multiply by the derivative of the stuff that's inside, which would be 3x squared minus 4. Okay, and I'm just going to stop there because it's homework. But this is the chain rule. You use the power rule in this case and then multiply by the stuff you have not taken the derivative of. Okay, well, this is also the chain rule. How come? Well, cosine of something is a function, and then 3x minus pi over 4 is also a function. So you have a function inside of a function. And so the chain rule says the derivative, start by taking the derivative of the main function, which is cosine. So the derivative of cosine would be negative sine of the stuff, right? Times the derivative, I'm going to write it like this, of the stuff. Okay, this is weird, but you'll get more used to it. It's negative sine of the stuff, whatever that is, and then times the derivative of that stuff. So we would say y prime equals negative sine of the stuff we started with, 3x minus pi over 4. But I haven't yet taken the derivative of that stuff, so I need to multiply by that, and the derivative of all of that would just be 3, for a final answer of negative 3 sine of 3x minus pi over 4. Okay, remember, this is only the third time you've done this. Like always, it gets easier and easier the more problems you do. All right, derivative, y prime. What is the derivative here? Well, let me put it to you this way. If I have y equals e to the stuff, the derivative will be, remember, the derivative of e to the x is e to the x. So the derivative of e to the stuff is e to the stuff. But you have to multiply by the derivative of that stuff at the end. And technically, you guys, we did this. So if I told you guys last chapter y equals e to the x, we said y prime was e to the x. We did the chain rule. Watch. The derivative of e to the stuff is e to the stuff times the derivative of the stuff, which was 1, giving us e to the x. So technically, we've been doing the chain rule, but because it was a 1, it didn't seem like we were. Okay, so let's jump in here and do it. We've got e to that. So the derivative would be e to that stuff times the derivative of the stuff, which would be 2x, for a final answer of 2x e to the x squared minus 4. The derivative of e to the stuff is e to the stuff, d stuff. Okay, over here we've got another trig problem. So y prime would be the derivative of sine of stuff is cosine of stuff, d stuff. So the derivative of sine of that would just be cosine of that times the derivative of the stuff we have not derived yet. And the derivative of 4e to the x is 4e to the x. So rewriting that to clean it up would be 4e to the x cosine of 4e to the x. Okay, so all we've learned is another rule on how to take derivatives, and then we go back and we redo, guess what? Tangent lines, right? They don't go away, which some of you might be annoyed with, but really you should be excited about that because you just spent an entire chapter learning it, so this isn't new. I know if I have a tangent line, I need a point, they gave it to me, 0, 5, and I need a derivative at that point. So this isn't new. What's new? What's new is this derivative. You have to know the derivative of this. Okay, so the derivative would be 5e to the stuff times the derivative of the stuff, for a final answer of 20e to the 4x. Well, if I need y prime at 0, that would be 20 e to the 4 times 0, which is just 20 because e to the 0 is 1. Okay, and once we have that, we have our tangent line is simply 5 plus 20 times x minus 0, and you're good to go. Okay. All right, this is a notation for composition function. I put this at the top. This is a pre-calc thing. This is the same thing as that. Oops, sorry. This right here is the same notation-wise as that. This reads f of g of x, just like this is f of g of x. Okay, so it tells us that h is f of g of x, find h prime of 1. So at the top of the next page, I'm going to rewrite the function. So remember, f of g of x is the same as f of g of x. Okay, so these are equal. They want me to find if h is equal to this. Okay, find h prime of 1. Well, let's find h prime of x. So h is equal to this guy. This is just the definition of the chain rule, which says take the derivative of the f function of the stuff times the derivative of the stuff, which is g prime. Okay, and so if I wanted to find h prime of 1, I just plug in. I say, well, it's f prime of g of 1 times g prime of 1 equals. Okay, let's find g of 1. G of 1 is 2. And so this would become f prime of 2 times g prime of 1 is negative 3. F prime of 2, ruh-roh, then give it to us. So what I'm going to do is I'm going to write that as an f, because that must be a typo. So f prime of 2, if it was equal to 5, we'd say it's 5 times negative 3 for an answer of negative 15. Okay. All right, so this is just notation. This might confuse you, but again, focus on this one. And to take the derivative on the front page, we show it to you. The derivative of f of g of x is just f prime g of x times the derivative of the inside stuff. And so when you write that out in notation, you get this, you plug in your 1 values, and you're good to go. Okay, the second rule of today is the derivative of any exponential function. So we have learned the derivative of e to the x, but this is any function a to the power of x. Okay, so if you're trying to find the derivative of a numerical value, right, to a power of x, this is what you do. You rewrite it, and then you multiply by the natural log of the base. Okay, so let me quickly just do some really simple ones to reiterate what that rule is before we jump into the hard ones. Okay, so let's say I have y equals 3 to the x. It told me that the derivative of a to some power of x is equal to a to the power of x, I just rewrite it, times the natural log of whatever the base is. Okay, so let's go do that. Y equals 3 to the x, y prime equals, rewrite it, 3 to the x, times the natural log of whatever the base is. That's it. Okay. If you had y equals 4 to the 2x, let's make it a little harder. What's y prime? It's just rewritten 4 to the 2x times the natural log of the 4. But don't forget, right, we have that exponent up there. Let me check to see if it goes into detail there. Yeah. So because we haven't taken the derivative of 2x, our chain rule says to multiply by 2. Okay, and so there's all these little pieces. They're easy to forget one piece or the other, but we just keep doing problems, and hopefully that gets easier. Okay, so back on the notes, let's practice a couple. So over here I have the function is equal to 3 to the negative x. Okay, so how do I take the derivative? Well, I know that I'm supposed to rewrite it 3 to the negative x. I know that I'm supposed to multiply by the natural log of the base. And then when you look at this, remember, you haven't taken the derivative of that stuff yet, which would be a negative 1. Okay? And how do I write that as an answer? You could write that as negative 3 to the negative x ln of 3, something like that. But these, again, would be multiple choice. You would just pick one that had all the parts. Okay, let's do the G one. So let's do it piece by piece. This is an exponential function. How do I know that? Because the exponent has the variable in it. Okay, there's not a variable as the base. So when you take the derivative of an exponential function, you just rewrite it. It's for sure 1/2 to the x squared plus 1. You also need to multiply by ln of whatever the base is. And then one more time, you have to multiply by the derivative of the stuff up here we never took the derivative of, which is 2x. Okay, and you can leave it like that. That's fine. No need to simplify. Order isn't really important there as long as you have all of the pieces. Okay. All right, let's come down here. And then, we're kind of over the exponential functions. This is not exponential necessarily. I mean, this little piece is, but I think we can use our old knowledge of that instead. So find the derivative. Okay, so these are getting a little more complicated because we have more rules, but really the rules are done at this point. Okay, we got the big ones out of the way. So this is a product rule. You have functions of x being multiplied together. So my derivative will be first e to the x. times, I do a big bracket because I'm going to have a big old derivative here, times the derivative of the second, which is 3 times x squared plus 1 to 1 smaller. I bring the 3 down, times the stuff to 1 smaller. Don't forget, times the derivative of the inside, which is 2x. Okay, product rule. First, derivative of second plus the second, which is x squared plus 1 cubed, times the derivative of the first, which is e to the x. Okay, when you get something like this, I encourage you guys to practice what's common in both terms, right? So we have this thing, which is a huge term, and we have this thing, which is a term. Are there any parts that are in common? Well, they both have e to the x, so let's take out an e to the x. And they both have x squared plus 1. This one has 3 of them, but this one only has 2. So I'm going to take out 2 of them. Remember, you factor out the smaller amount. Okay? And then what's left? Well, let's look at our first term. I took out e to the x. I took out all of those. So all that's left is a 3 and a 2x, which is 6x. Plus, what's left in this term? I took out the e to the x. I took out 2 of those, so there's still an x squared plus 1 left in there. Okay, if it was a multiple choice question, they would simplify that to just that times, and then we'd put this in standard form, x squared plus 6x plus 1, which can't be factored, and you guys could stop there. Okay. All right, one more here. Let's take the derivative of this guy. So a little note, if you have y equals cosine squared of x, you guys really need to remember that that's cosine of x quantity squared. Okay, and so that's going to come into play here. I'm going to rewrite this up like that so you can see what it is. So this is really, this is squared. So you could keep the 5 outside if you want, but really it's just 5 cosine of 3x plus 2 raised to the power of 2. That is the hardest part of this problem. This is a common mistake here. That squared is on this trig function, not the x. So it's the whole trig function squared. Now this is going to be way easier. To take the derivative of this, we use our power rule. So let's bring our 2 down. 2 times 5 is 10. Cosine of 3x plus 2 to 1 smaller. But then don't forget derivative of the inside times the derivative of all of this stuff. Okay, so let's do that. The derivative of cosine would be negative sine of this stuff. And then we never took the derivative of that, so that is times 3. Okay, so y prime, cleaning that up, I've got 10, a minus sign, and 3, which makes negative 30. I've got cosine of 3x plus 2, and I've got sine of 3x plus 2. Okay? All right, let me do, just because that was a little bit harder, let me do one more example. So what if I gave you guys y equals 2 sine squared of 4x? Okay? Let's practice this one and I'll be done. So let's rewrite this. That's 2 times sine of 4x all to the power of 2. I have not taken the derivative yet. Okay? So let's now take the derivative. I know when I have a power, I bring it down to make 4. I know I remultiply by all that stuff to 1 smaller. And then I never took the derivative of the stuff that's inside, all of that. The derivative of all of that would be cosine of 4x. But then I still haven't taken the derivative of the 4x, so I need to multiply by the derivative of 4x, which is 4. How do I know I'm done? It's a good question. Well, I did the power rule, so I took care of the overall function. Then I multiplied by the derivative of this, which was cosine, but I never took the derivative of 4x, so I have to also take the derivative of that. For a final answer there of 16 sine of 4x cosine of 4x. Okay. All right. This is definitely, to me looks like If they're going to ask 2 questions with chain rule, this would be the second question on the multiple choice test. That would be the harder version, right? Because there's 2 chains there. There's this guy plus that guy. Okay, hang in there. The homework will solidify it. Remember, it's a new week. This is our last chapter of this quarter. This week will be uncomfortable because of all of the homeworks, just like the last 2 chapters. But when I see you guys tomorrow in your Zoom or Wednesday in your Zoom, as usual, I will do probably half of that whole homework assignment for you. We'll work through it together, and you'll solidify your questions. You've always got Khan Academy you could look up videos on. You could go in your book and look up chain rule. There'll be examples in there, things like that. You can be proactive if you're nervous about it. Okay, take care, guys.